In the era 1968, Douglas Engelbart unveiled the first computer mouse and interactive windowing system at his legendary demonstration. Then, in 1973, Xerox Alto was the first computer to use a desktop metaphor with a mouse and graphical elements. As the years passed, the GUI became more advanced and reached the level where it is now. So today, we are diving deep into the GUI and learn how they show things on the screen. The GUI is heavily based on a coordinate system. Every visual element on the screen relies on mathematical coordinates to function. The screen is treated as a two-dimensional grid of horizontal and vertical axes. Unlike traditional math charts, the computer screen coordinates almost always start with 0, 0 at the top left corner, while the coordinates go down as the y-axis increases. But this has a problem. The display size in these modern days are unpredictable. So, René Descartes invented the Cartesian coordinate system, where 0, 0 is in the center. But the computers only know the pixel coordinate system. So, the way you convert them into Cartesian coordinates is dividing the width and height of the screen by 2 and adding the specified coordinate to it. And the main thing, we need to negate the y-axis for it to work, because the pixel coordinates have the y-axis increasing as we move down, which is completely opposite from the Cartesian one. In this way, the coordinates are centered and 0, 0 is the center of the screen in every screens, and the values are in floats or doubles and not always in integers. Now, after eating all of this knowledge, let's jump into coding and learn how to implement these things. I am using Java Swing to demonstrate the system. You can use anything. Start by creating a simple window. I am assuming you have got a basic JFrame up and running, so we can focus strictly on the coordinate math today. Now you have a window. Now we will make a small method to draw a point. So let's create a method. Public void drawPoint as Cartesian. Then let's add the parameters graphics g, float x and float y. Then we will make a variable called screenx and implement our conversion system. First, we will divide the screen width by 2. Then we will add the x variable and cast it to int. Then let's go up and make some variables. First, we will create a magnifier integer. This is the scale factor for the coordinates. This is what we will multiply to the x value to get the coordinate system to be using a human-like scale. Otherwise, it would become pixel by pixel. I will make it 50, you can choose anything. Then we will make another integer variable called point size. This will be the size of our point that we will draw. We will make it to be 5 pixels so we can see it clearly. Then let's head back to the method. Multiply the magnifier to the x value and subtract point size divided by 2 to get the point as where we wanted it to be. Then for screen y, divide screen height by 2 and add the negated y value and multiply the magnifier to it. Negating the y value is crucial here, as I have explained why, and also subtract point size divided by 2 because fill oval draws from the top left corner of the bounding box. We subtract half of the point size so that the center of the dot aligns perfectly with our coordinate. Then we will set the color to be white and call the method fillOval from the graphics API. Then we will add screen x, screen y and the point size. Then let's call this method in the paint component method. Then give it the graphics API and the coordinates. I will specify the x coordinate to be 2 and y be 4. Let's see how it renders it. So, as you can see, the coordinates are appearing as expected on the screen using the Cartesian system. If you have messed up somewhere, don't worry. I have prepared a GitHub repository for you to inspect my code to see how it works. Link is down below in the description. Then what we need to do is to build a small graphing system that can draw points along with lines, triangles and more. All of that are covered in this video. If the video is not out yet, this is the video that YouTube thinks is best for you. Thanks for watching.